Okay, so we've connected the viscometer to the PC via a USB machine. The viscometer is running, and we have a sample on the plate and it's ready to run. So this is a demonstration of how to use the PC software. The PC software actually has two modes. There's a flow curve program, which essentially allows you to measure the viscosity as a function of shear rate, starting from one shear rate and running to a second shear rate. You can also set the temperature and how long the experiment should take. The second mode is a time curve. This will make measurements at a single shear rate, and it will plot the results as a function of time. So this is used typically when you're looking at something like a resin that's curing. So let's look first at the flow curve software. The first thing we need to do is to connect the machine to the PC. So we press Find Machine, and it will tell us that we're connected to a viscometer and give us a serial number, so as we know we're connected to the right machine. We then go through and set up our experiment. So I'm going to run from 200 RPM to 600 RPM at a temperature of 25 over the course of 300 seconds, 5 minutes. The cone is a 10 poise cone, and I want the results in poise. Having set up the experiment, we press Set Parameters. Now you'll see on the screen of the viscometer itself at this point, it will have come up with the USB connection active screen, telling us that the PC is now in control of the instrument. Okay, on the graph inside we've got a couple of information options. We can plot the graph as a 3D graph. We can actually plot the viscosity data points against each point, and we can show the max and min viscosity. On a flow curve we don't particularly want any of those. Having set up your parameters, then you simply press Start. The viscometer now is recording the data as it spins up from 200 RPM to 600 RPM. Okay, so at the end of the test, the computer will tell us that it's completed the test. So we simply need to press OK on the info box. We now have a number of options. The viscometer as standard puts the serial number and the date and time onto the top of the graph. We can add a subtitle if we wish. So we can call this sample, and it will appear as the second line on the title. We can save the graph, and it will save the data as a comma separated variable file, and that will then take us into the Windows file save menu. Or obviously we can load a previously saved graph if we just want to display the data. The printing function uses the Windows print functions, so any Windows printers we've already got set up, we can simply select and then print. So that's pretty much it for flow curves. For a time curve, the setup is broadly similar. We simply check the time curve box you'll see the second shear rate has now disappeared, and we've got the option of setting up the experiment pretty much as before. All of these boxes we can select, so for example RPM, or we can have reciprocal seconds as the shear rate. We can handle temperatures in centigrade or Fahrenheit, and time in seconds or minutes. Again, we'll stick with the 10 poise cone and do the results in poise. So having set up our experiment, let's go for 375 mid-range viscosity, mid-range speed. We can now set the parameters again. This will reset the graph, and you can now see that we have time in seconds on the X scale now. Having set that up, just simply press start to run the test. Now, an important point with all of these functions, and this is particularly important for people dealing with resins, is I can stop the test at any time. So essentially I've now cancelled the test, we've recorded the data up to wherever we stop, and we can save that data. So if looking at resin cure, for example, we might set a time much longer than we need and just simply stop the test when we've got enough data. Again, you can save and load the data as before. And that's pretty much it for the software. There are a couple of additional functions available. The terminal basically allows us to see the data coming from the machine. That's sometimes useful in diagnostic tests. And that's it really.